All right, so today we are starting Unit 3, which is your unit on triangles. The best part about this unit is it should be really familiar for you. The entire thing isn't necessarily a review, but you do have some background knowledge that you learned a long time ago when you were a kid. So we'll be able to pull that knowledge and then kind of go from there. So what we're looking at today is we're going to go over sides, vertexes, and angles of triangles, and then we're going to do a knowledge check on that. Then we'll go over isosceles scaling, right, equilateral. I'm forgetting the names of the other ones right now, but we'll go over all of those, and then we'll do a quizzes over that. And then that's kind of where we'll pick off next class. So when talking about geometric figures, Euclid falls back into place. He has all of these definitions. So definition 13 says, a boundary is that which is an extremity of anything. Okay. Definition 14 says, a figure is that which is contained by any boundary or boundaries. So back to Euclid, he now makes the transition to geometric figures, which are created by a boundary, which separates a region into that which is within the figure, that which is not. So essentially everything we've been doing before this moment wasn't about an actual shape. It was about like a point, a line, a plane, things like that. Now we're going to look at actual shapes, okay? So definition 19, rectilinear figures are those which are contained by straight lines. Trilateral figures being those contained by 3, quadrilateral, those contained by 4, and multilateral are those contained by more than 4 straight lines. In this unit, we'll be discussing triangles, which are an example of a rectilinear figure, a figure bounded by line segments. So this is when we start to look at actual triangles. And a triangle is a closed figure bounded by 3 line segments. So Euclid's definitions 15 all the way through 18, which we just talked about, relate to circles, which we'll talk about later. So there are parts of a triangle. This part is very important, okay? So a triangle has 3 sides and 3 vertices. So let me highlight these, okay? So 3 sides, 3 vertices. So we have a side right here. So one of the sides is BC. One of the sides is AB. One of the sides is AC. So those are the sides. Our vertices are where the sides come together. I should be highlighting these words with the same color. So we've got that. And I'll go back and put this, our sides, in pink. And then we also have angles. And there are 3 of them. So we have an angle B, which is where sides C and A come together. We have angle A, which is where sides C and B come together. And we have angle C, which is where sides B and A come together. All right. It is standard to label vertices with capital letters and sides with lowercase letters. It's also standard to label the side opposite of angle A with a lowercase a. So what does that mean to us? Angle A and the side opposite with a lowercase a. So angle A is right here. And if you go directly across from it, you'll notice the side across from it is labeled with a lowercase a. We can further that example and look at it one more time here with blue. You could say C. So we have this angle right here, which is C, and the side across from it is a little baby c. All right? Questions on that? Okay. So when we talk about the parts of the triangle, there are 3 vertices of A, B, C. And in this case, they are A, B, and C, which I just highlighted for you. There are 3 angles, angle A, angle B, and angle C. And there are 3 sides. Notice here, and this is what's going to try and trip you up on the knowledge check, you have to have these lines over the top when talking about sides, okay? So the 3 sides are AB, BC, and AC, okay? Or you could also call them A, B, and C. So this right here would either be BC with a line over the top of it, or A. Either way, it's the same thing. The measures of the angles are measure of angle A, measure of angle B, and measure of angle C. The measure of the sides are AB, BC, and AC, okay? So it's important that when you're talking specifically about the sides, you have the line over the top. If you're talking about the measure of the sides, you do not have to have the line over the top. So we have parts of a triangle. A side is opposite of an angle if it does not touch it. Otherwise, it is adjacent to the angle. So in the above picture, the red side is blank to angle A. It's opposite. Because you look here and you say, all right, here's angle A, and this red line is across from it. The green sides are blank to angle A. They are adjacent because they touch it. Okay? Questions on that? All right, so you have a knowledge check now. The only thing that I can think of on this knowledge check that we didn't talk about is if we were to name this triangle, you can name it with the 3 vertices, which in this case are capital A, B, and C. But it doesn't have to go A, B, and C. It could go B, C, A. It could go C, A, B. It could be any of those orders. All of those are ways to name this triangle. So you have 10 minutes for the knowledge check. I will call you back in at 1:38. And your knowledge check is located right here. It is called Parts of a Triangle 1 through 6. I will call you back in at 1:38. Let me go ahead and stick you guys in. All right, guys, you should be finished with your knowledge check. I'm going to play the video for some, and then I'll explain other ones. Ones that I feel like I've already explained, I'll let her explain. That way you get 2 different perspectives. So here we go.
What names the side shown in red? All right, well, line segment AB is here, so it's not 1. And B is a vertex or an angle, but it's not a line segment, so it's not going to be 2. AC is the measure of this line segment, but it's not actually the name of the line segment, so it's not 3. And here we have the line segment AC. It could also be written as line segment CA, and it is correct. This is what we would call this side right here. So the answer is D.
All right, here we go. Question number 2. Which side is opposite of angle A?
Which side is opposite angle A? All right, well, angle A is here. So this is the side that's opposite, and this would be line segment CB or line segment BC. So let's see, we have line segment BC right here. So the answer is D.
All right, questions on that. The third question wants to know which of the following names the triangle. So remember, you can name it with any 3 letters, and order does not matter.
Which of the following names this triangle? Well, we have 3 vertices, A, B, and C, and we can actually name the triangle any order of those 3 vertices. So we could do ABC, we could also do BCA, or ACB. Any order of the vertices will work fine. So the answer is D, all of these.
All right. Moving on to question number 4. 3 statements are true and 1 is false. Identify the false statement.
3 statements are true, 1 is false. Identify the false statement. All right, A. Lowercase a names the segment joining B to C. That is true. This is the name of this segment, so that's true. Capital B names the vertex where A meets C. Right, so here we have B, and that is where lowercase a meets lowercase c, so that is also true. Lowercase a, b, and c are the names of the sides of triangle ABC. That is true. And finally, BC equals A. Well, almost. If there was a line segment here, then this would be true. But BC, without the line segment symbol, is just measuring the length of it. So this is not true. The answer is D. BC is a number, and A is a segment.
So, like I said at the beginning, it's really important that you have that line above it because it distinguishes something else. So if we look at question 5, I'll go over this one. Which sides are adjacent to angle C? So if we want to talk about angle C is right here. And by highlighting angle C, which the angle itself starts right here, that's the vertex. In highlighting that, you notice that I've highlighted side A and side B. So your answer choice A is the correct answer choice. If we look at question 6, 3 statements are true and 1 is false. Identify the false. So it says P is a vertex. Well, P being a vertex makes sense because we notice P is right here at the vertex. It says that R is a side. That works. I can actually mark these with true if it helps you. QR is the name of a side. Well, QR is kind of the name of the side, but notice it's missing this line over the top. Therefore, this one is false. QR being the length of the side is okay without having the line above it. But if you are going to name a side, you need to make sure that you have that line above it. So I understand that was a little bit tricky. We'll have a lot more practice on that. Thanks for hanging in there. So let's go ahead and talk about types of triangles. And this one should be really simple for you, and it should be review. So in general, a triangle can have sides of different lengths and angles of different measure. However, there are names given to triangles which have specific or special angles, or some number of equal sides or angles. So Euclid defined the names for a number of these in his definition. So the very first one we're going to talk about is how to classify it by sides. So definition 20 that Euclid came up with said, of trilateral figures, an equilateral triangle is that of which has 3 sides equal. An isosceles triangle is that which has 2 sides equal. And a scalene triangle is that which has 3 sides equal. So I'm going to go ahead and write these on here. So notice he's only talking about sides in this. So equilateral, 3 sides equal. Isosceles has 2 sides equal. And scalene has no sides equal. Okay? So triangles can be classified by their sides or by their angles. In this definition, definition 20, Euclid uses the sides. In his next definition, Euclid uses the angles. So you can name a side using the words equilateral, isosceles, and scalene, which I believe you should have learned like a long time ago. When we talk about definition 21, further, of trilateral figures, a right angle triangle is that which has a right angle. An obtuse angle triangle is that which has an obtuse angle. An acute angle triangle is that at which has 3 acute angles. So for a right triangle, you have, get my text box, you have 190-degree angle. You have, for an acute one, you have 3 acute angles, which means that they are less than 90. And for obtuse, you have 1 obtuse angle, which means that one of the angles is greater than 90. All right, do we have any questions on this classifying triangles? No? I'll give you a second. Okay. So typically, we would start a knowledge check. I'm going to go over this slide, and then we're going to do a quizzes this time instead of a knowledge check. So reviewing this again, there are types of triangles. The modern definitions are these. An equilateral triangle is a triangle with 3 congruent sides. An isosceles triangle is a triangle with at least 2 congruent sides. So it could have more congruent sides, but it has to have at least 2. A scalene triangle is a triangle with no congruent sides. A right triangle is a triangle with 1 right angle. An obtuse triangle is a triangle with 1 obtuse angle. An acute triangle is a triangle with 3 acute angles. An equiangular triangle is a triangle with 3 congruent angles, all right? So like I said, typically we would go into the knowledge check, but I want to kind of see what you remember from the past before giving you the knowledge check. So we're actually going to do a quizzes. So you can go ahead and get logged in. If you're watching the recording of this, you don't have a way to do the quizzes, so you are finished. If you are in my live class, you are doing the quizzes. So there's 25 participants and 24 people should be logged in.